Kia ora. Here are the last couple of questions that are at merit level on last year's complex numbers paper. So just looking at them before we start. In this one here, we've got an equation where we're given one of the solutions and we've got a missing coefficient here. So we're told that if A is real, we have to figure out the value of A and the other two solutions of the equation. So things that we're going to use in there, we're going to use the conjugate root theorem for sure to get the second root, and then we're going to do a little bit of work to factorise this. And you can either use long division for that or just do it with matching up, which is what I'm going to do. The second question here is a surd equation where we're going to end up doing some squaring on both sides and some rearranging, and we have to solve for x in terms of m. So my goal is to end up with x equals blah, blah, blah. Okay, let's look at this first one. So here's my polynomial, and we're told that one solution is this, z equals 2 plus 5i. So we'll call that z1. So the second solution is going to be 2 minus 5i, and that's by the conjugate root theorem. So what we can do from there is we can work out what the quadratic factor is as follows. So we know that 2 plus 5i is a solution, and we know that 2 minus 5i is a solution. So the best way to expand this is to group up the real bit with the z. So rewrite it like this, z minus 2 minus 5i. And if you're in 13 MCA, this is exactly what we were doing yesterday. Right, so just do that little bit of rearranging with some brackets, and it's now really easy to expand. So we get z minus 2 squared. These go, and we get minus 25i squared, which is plus 25. So we can very quickly get the quadratic term here, which will be z squared minus 4x plus 29. So that's the first bit. Now looking back at what we've got, we're going to take this and figure out the linear factor. So 4z cubed minus 19z squared plus 128z plus a is equal to this, z squared minus 4x plus 29 times something. So let's just look at doing the something by matching. Well, we've got to get 4z cubed, so this has to be 4z. We don't know what this is, which is a bit of a pain, but we can match up and figure out, oh, I've got an x in there instead of a z. Let's just fix that. So we've got a z here. If we're going to end up with negative 19z, then we can match that up with the right-hand side. Negative 19z squared is going to come from two places. It's going to come from here, negative 16z squared, and then the rest of it has to come from this, plus kz squared. That means that k has to equal negative 3. So that means that the last factor, or the linear factor, is 4z minus 3. And that will equal 0 when z is equal to 3/4. So now I've found my three solutions. I've got z equals 3/4, and I've got the first one we were given. So these are the three solutions, but I also have to find the value of a. But now that I've factorized that, we can do that very easily from here, right? So we know that a is equal to 29k. So coming from that very last term, so 29k will be 29 times negative 3, which is negative 87. So there you go. That's the first question done. Now let's look at the second one. Okay, so we've got some surds on both sides. You just need to read it really carefully to make sure you see where the surd sign stops. So in this case, what we've got is this. So 6, just writing down again, 6 root 2x minus 5 is equal to 6 root 2x plus m. Now just don't go too fast because it's pretty easy to stuff it up and write it like that. That's not what we're working with. The best thing to do here is just to get on with it and square both sides. So squaring both sides of the equation is really easy on this side. 6 squared is going to give me 36, and then this bit here will give me 2x plus m. Over here, we'll just write that out to start with, like this. And now in the next line, I'm going to expand the brackets on the left-hand side. So expanding here, we're going to get 36 times 2x. Then I'm going to have minus 2 lots of 5 times 6 root 2x plus 25. And expanding over here, I get 72x plus 36m. So happily, a couple of things simplify away. So this is 72x and this is 72x. That leaves me with, what have we got here? So negative 60 root 2x plus 25 is equal to 36m. Remember, my goal is to get x as the subject. So we're going to have negative 60 root 2x is equal to 36m minus 25. I don't know why I did it that way, but I did. Let's just wash everything through by negative 1. So 60 root 2x is 25 minus 36m. Root 2x is equal to 25 minus 36m divided by 60. Now I'm going to square both. Am I going to square both sides? That x is inside the square root sign, so be really careful with that. Make sure it's still in there. Squaring both sides is going to give me 2x is equal to all of this squared. So let's do it separately. Squaring the numerator, we get that, and squaring 60, we get 3,600. So my final answer here is this. It's fine to leave it like that. I think I'd stop there. You could also go on and expand that out. But there's no common factors going to come out of that, so I probably wouldn't bother. And when I checked the schedule, that was where they left it. But if you do expand it out, I'll just show you what you should get down to, just in case anyone did that. So we get 25 squared, 625, minus 25 times 2 times 36, so 50 times 36, minus 1800m, plus 36 squared, not a square number that you need that often, but there it is, 1296. Okay, so that's your final answer there. But really, I think we just stop there because it looks nicer. Thanks for watching. That's all for now. I will do a couple more complex number revision questions later on today.